Dear learners, welcome you all. In this lecture, we are going to discuss about problems related to open circuit short circuit test. Problem: obtain the equivalent circuit of a transformer 200 bar 400 volt 58 single phase transformer from the following test data. Open circuit test 200 volt, 0.7 amperes, 70 watts on low voltage side. Short circuit test readings are 15 volt, 10 amperes, 85 watts on high voltage side. This is a problem given here. From this, write the given data. So, open circuit test, V0 is equal to 200, I0 is equal to 0.7, W0 is equal to 70. So, in open circuit test, we are going to find the iron losses. Next given data is short circuit test. In this, you are going to find the full load copper losses. So, short circuit voltage 15, short circuit current 10 amperes, short circuit power is equal to 85 watts. In this, you are going to find the full load copper losses. Next, what is given? V1 200, V2 400, frequency is given as 50 Hz. These are your given data. What you are going to find? We are going to draw the equivalent circuit. To find the equivalent circuit parameters, R01, X01, R1, X1, these are the parameters we are going to find. This is the equivalent circuit. R1, X1, R0, X0, I mu, IW, R2, X2, these are the parameters we are going to find in the equivalent circuit. This is your equivalent circuit or transformer. Now, this is your ideal transformer. This is your equivalent circuit or transformer. Finally, the value is nothing but R01, X01 we are going to find from this value. So, first thing, solution. From open circuit test, we are going to find the parameters. What are you going to find? We are going to find the no load parameters. The no load parameters are I mu, IW. From that, you are going to find the value of X0 and R0. W0 is equal to V0, I0 cos theta naught. W0 is 70, V0 is 200 voltage, I0 is 0.7, and from this, you are going to find the power factor. So, 70, 200, I0 is 0.7 cos theta. So, cos theta is equal to 70 divided by 200 into 0.7, gives us 0.5. So, cos theta is equal to 0.5. Take the cos inverse, yes, 60 degree. Now, find sin 60 is equal to 0.866. This is your sin theta value. So, transformer ratio is very important because from this value, we are going to find the value of K. So, K can be divided as V2 divided by V1, E2 divided by E1, N2 divided by N1 is equal to I1 divided by I2. That also you can find the transformer ratio. In this, we know the value of V2, V1 and V2. So, V2 value is 400 and V1 value is 200. So, K is equal to 400 by 200 is equal to 2. The value of K is 2. This is very important to find. So, these are given data. From the given data, you are going to find the working component. So, for the equivalent circuit, what is it? As I told you, we need to find the value of IWIC. So, IWIC is equal to I0 cos theta naught. I0 is equal to 0.7. Cos theta naught is equal to 0.5. This has been found in the problem. Substitute the value. So, you get this current as 0.35 amperes. This is your working component. Next is your magnetizing component I mu. I0 and sin theta naught. So, I0 is 0.7, sin theta naught is equal to 0.866. So, you get the I mu value is equal to 0.606 amperes. These are your no load working component and magnetizing component. From this, we are going to find the value of R0 and X0. So, R0 is equal to V0 divided by I mu. What is V0? V0 is equal to 200. I mu is equal to 0.35 amperes. So, you get this as R0 is equal to 571.4 ohms. This is your R0 parameter. Next, you are going to find the X0. X0 is equal to V0 divided by I mu. So, V0 is equal to 200. I mu is equal to 0.606. You substitute the value gives us 330 ohms. So, these are your no load parameters. These values are found from the open circuit test. In open circuit test, we are going to apply the rated voltage. Remember that. So from short circuit test we are going to find. In short circuit test you are going to find the copper losses. So copper loss nothing but WSC. So you are going to find this Z0 value. Z02 is equal to VSC divided by ISC. VSC is equal to 15 divided by ISC is nothing but 10. So 15 by 10 is nothing but 1.5 ohms is your secondary impedance. Same thing, WSC is equal to this is copper losses. So ISC square into R02. So ISC is nothing but short circuit current is equal to 10 square. R02 value we have to find. So WSC is equal to 85 and ISC square is 10 square. So R02 is nothing but 0.85 ohms. This is your R02 value. So we know the value of impedance, we know the value of resistance. We need to find the value of X0. So X0 is equal to root of Z0 to the whole square minus R0 to the whole square. So Z02 value is 1.5 and R02 is nothing but 0.85. So the X0 value is 1.24 ohms. This is a value referred to secondary side. Similarly, we have to find the value referred to primary side. Z01 is equal to Z02 divided by K square. We are moving the secondary resistance, reactance and impedance to primary side. So this is nothing but divided by K square. Z01 is equal to Z02 divided by K square. What is the value of Z02? Is 1.5 divided by 2 square is equal to 0.375. Again similarly for R01 divided by K square, R0 is nothing but 0.85 divided by 2 square, because R01 is 0.21 ohms. From this you can find the X01 primary leakage reactance. X01 is equal to impedance Z01 the whole square minus R01 the whole square. So Z01 is equal to 0.375 the whole square minus 0.21 the whole square, given as X01 is equal to 0.31 ohms. So these are the parameters. Now substitute these values in the equivalent circuit. This is the equivalent circuit. The equivalent circuit parameters are R01, X01, R0, X0, I mu, IW. These are the no load parameters. These are your primary parameters. So these are the parameters we have found: IW, I mu, R0, X0, R01, X01, Z01, R02, X02, Z02. These are the values we have found from the calculation. Now substitute these values in these parameters. So I mu is a magnetizing current, is a 0.606 amperes current flowing in this. IW is a working component, is 0.35 amperes. X0 330 ohms, R0 571.4 ohms. These values are found from the no load or open circuit test. So next is your R01 0.21, Z01. From these two values you can find the value of Z01. So this is the equivalent circuit. This is how we are going to find the parameters of the equivalent circuit. Similarly, same procedure should be repeated for your lab experiment also. So now another problem, take this as your homework and try to solve this. A 500 kVA 3300 bar 400 volt 58 single phase transformer is given below. Short circuit test 1200 watts 100 volt. The short circuit current at full load. Open circuit test 1000 watts with a normal primary voltage. Calculate the full load regulation and efficiency at 0.8 power factor lagging. So this has been given. From this we are going to solve the problem. Try this out. The formulas has been given in your the formulas has been explained in the previous slides. Hope all have understood the problem related to open circuit short circuit test. Let's all meet in the next session. Thank you.